Hey everyone, and welcome. If you've ever looked at building on Cardano and thought it seemed like this massive, impossible mountain to climb, well, you're in the right place. Today, we're going to approach it as a journey, a step-by-step adventure. We're going from your very first interaction on the blockchain all the way to building a full-blown dApp. Let's get into it.
So here's our game plan. We're going to start with the absolute basics, then we'll get you set up with the right tools for the job. After that, we'll pull back the curtain on how Cardano's contracts really work, write some actual rules, and most importantly, learn how to make them super safe and secure. And to top it all off, we'll look at some pro techniques that make dApps sing.
All right, first up, every single amazing, complex dApp you see out there, guess what? It all started with one tiny thing, a single transaction. And that is exactly where we're going to begin.
Your big hello world moment on Cardano is just sending that first transaction. And with a tool called the Mesh SDK, it's really just 3 simple steps. First, you generate a mnemonic phrase. Those secret words that act as your master key. Second, you use that phrase to get a wallet up and running. And finally, you build and fire off a transaction. This right here, this is the fundamental building block for everything else we're going to do.
Okay, so every dApp really has 2 sides to it. You've got the on-chain logic, these are the permanent rules of the game. And then you've got the off-chain user interface, the website a person actually clicks on. You absolutely need the right tools for each part.
Now, this is where things get really clear. Just think of it like this. Omicron is a language you use to write the laws of your application. These are the rules that are going to live forever on the Cardano blockchain. The Mesh SDK, on the other hand, that's what you use to build the beautiful front-end web app that lets people actually use those laws. So one writes the rules, and the other builds the front door.
Okay, this next part requires a little bit of a mental shift. Seriously. If you're coming from other blockchains, you probably think of smart contracts as these little programs that live on-chain and hold on to data. On Cardano, it's a totally different way of thinking. It's all about one thing, validating transactions.
So here's the key. In the Cardano world, we don't really say smart contracts. The much better word is validator. A validator doesn't hold your funds, it doesn't store data itself. Nope. It's just a program, a set of rules. And when a transaction shows up, its only job is to look at it and give a thumbs up or a thumbs down. Yep, this follows the rules, or no way, this doesn't. It's basically a bouncer at the door of the blockchain.
And this flow right here shows it perfectly. A user comes along and presents some UTXOs. Just think of them like unspent dollar bills in your wallet, as inputs. Then, the validator script runs and it checks everything. Did the right person sign? Is the right amount of money being sent? And if, and only if, every single rule passes, then the old inputs get spent and new outputs, new UTXOs, are created. It's that simple.
Awesome. Now that we've got the core concept down, we can get our hands dirty and look at the different kinds of rules we can actually write. Aiken lets us create these validators for really specific jobs. You're mostly going to run into 3 main types. Spending scripts, which kick in whenever someone tries to spend a locked-up UTXO. Minting scripts, which, you guessed it, control the creation or destruction of tokens. And finally, withdrawing scripts, which are for pulling out staking rewards, though they have a super clever other use that we're going to get to in a bit.
And hey, don't let the code scare you. At its heart, an icon validator is ridiculously simple. This little snippet right here, that's a complete working validator. It's just a function that takes in some transaction info and literally just returns true. That's all it does. If the conditions are met, a validator just has to return true, and the transaction gets the green light.
Okay, making something that works is one thing, but making it robust, secure, and professional, that's a whole other level. See, good code isn't just about what it does, it's about how it handles every single possibility, both good and bad.
So, the very first step in testing is what we call the happy path. This is where you test the perfect scenario. You pretend the user does everything right, provides all the correct info, signs where they're supposed to. The big question is, does your contract work as expected? You got to check this first.
And this is pretty much what that looks like in code. A test function like this success_continue counting one, it just builds a fake, perfect transaction. It's got all the right inputs, all the right signatures. If your validator returns true, the test passes. Boom. You've just proven the happy path works.
But here it is. This is the secret to real hardcore security. The happy path is the easy part. Great developers, they spend most of their time testing all the unhappy paths. What if someone tries to cheat the system? What if they send the wrong data or forget a signature? A truly secure contract has to slam the door on every single invalid attempt. And the magic word here is fail. This test is supposed to fail. We're intentionally building a broken transaction, and the test only passes if our validator does its job and rejects it. This is how you build bulletproof confidence that your code is actually secure.
So you've got your on-chain Aiken code over here and your off-chain Mesh app over there. How in the world do they talk to each other? The answer is this thing called the blueprint. When you compile your Aiken code, it spits out this standardized JSON file. It's basically an instruction manual. It perfectly describes your validator and tells your web app exactly how to format its data to talk to the on-chain rules. It's the ultimate translator.
All right, we've got secure, working validators. Now let's level up and look at some pro techniques. These are the kinds of patterns that take a good dApp and make it truly great. Smarter, cheaper to run, and way more elegant.
Just imagine you have a really complex transaction with, say, a spending script and a minting script. What if they both need to check the exact same thing, like making sure a specific person signed off on it? Do you really want to run that check twice? Because every single check you run on-chain costs the user real money in transaction fees.
And here is the genius solution, the withdraw zero trick. Remember those withdraw scripts we talked about? Well, some clever developers figured out you can trigger one just by trying to withdraw zero loveless. So what you do is you put all your common shared checks into one single withdrawal validator. Then, your other scripts only have to check one simple thing. Did that central withdrawal validator run successfully? This way, the heavy lifting only happens once, saving everybody money on fees. It's such a cool and clever pattern. This idea of combining simple validators lets you build some really complex stuff. Take a unique NFT contract, for example. You could have one validator whose only job is to mint a single, unique Oracle token. Then, a second validator controls that Oracle, and it uses its data to keep a counter, like how many NFTs have been minted so far. Then, your third validator, the actual NFT minting script, doesn't have to worry about tracking anything. It just looks at the Oracle's data to get the next number, guaranteeing that every single NFT is unique.
So, let's wrap up our journey. What do we learn? The big one is that Cardano uses validators, not old-school smart contracts. We know that dApps have two parts, on-chain rules with Aiken and off-chain user interfaces with Mesh. We learned that real security comes from testing for failure, and we saw how smart patterns like that withdraw zero trick save money, and how combining simple validators lets us build really powerful things.
We've literally gone through the entire journey, from one tiny transaction all the way to the patterns used in the most complex dApps. You now have all the fundamental concepts, the building blocks you need to create something totally new on Cardano. So the only real question left is, what are you going to build first?